All right, discrete math. Well, here we are, 3.6. This is officially the last section for chapter 3, which means it's the last section that'll be on midterm number 2. Also, the last section that will be on the final exam. Also, the last section for the entire year. So, it's been a pleasure, guys, going through all these crazy, wacky, cool topics with you. If you have any questions, feel free to reach out, and I hope that you are still doing well. So this last section, chapter 3, is 3.6. It's what's called the method of markers. So method of markers is the most recent game that we're going to look at. This was a discrete fair division method that was proposed in 1975 by William F. Lucas, who is a mathematician at Claremont Graduate School. Method has great virtue in that it does not require the players to put up any of their money. So unlike the method of sealed bids, this method can't really be used effectively unless there's a lot more items to be divided than there are players in the game. So it wouldn't work well for the example of Grandma's estate. Second thing is the items have to be relatively close in value, meaning that you can't have a car, a house, and a painting where the values are crazy different prices from each other. So in this method, we start with items lined up in a random but fixed sequence that we're going to call an array. Best way to think about that is just having them all lined up on a table and that they're all in a straight row. Then what's going to happen, each of the players is going to make an independent bid on the items in the array. A player's bid is going to consist of dividing the array into equal segments, as many segments as there are players. So if there's 3 players, then they're going to divide the bounty up into 3 segments, 5 players into 5 segments, and so on. Okay, so for convenience, we might think of an array as a string, and so each player is then going to cut your string into n segments, each of which they would consider to be an acceptable share. Notice that to cut a string into n sections that you need n minus 1 cuts. So if you're going to have 3 sections, that means 2 cuts, 5 sections, 4 cuts, and so on. One way to make the cuts is to lay markers, hence the name method of markers, in the places where the cuts would be made. Thus, each player can make their bids by placing markers so that they divide the array into n segments. So, the other thing, to ensure privacy, no player should be seen or should see the markers of other players before laying down his or her own bid. The final step then is to give to each player one of the segments in his or her own bid. Again, this will probably work best if I explain it with an example. So, we're going to divide up the Halloween leftovers. We've got Alice, Bianca, Carla, and Dana, who went to divide the Halloween leftovers that are shown in the picture. There are 20 pieces, but having each randomly choose 5 pieces would not likely work out well. Pieces are too varied for that. So their teacher, Mrs. Jones, offers to divide the candy for them, but the children reply that they just learned about a cool fair division game that they want to try on their own. And they can do it by themselves. Thank you very much. Okay, so they arrange the candy into an array, so you can see what that array looks like. There were too many to fit kind of all in a single row, so just know that it wraps from 10 back to 11 and then across to the right. So the first step, step 1, the bidding. Each player is going to write down independently on a piece of paper exactly where they want to make their 3 bids or place their 3 markers. They're going to divide the array into 4 sections that they consider to be acceptable. The bids are opened and the results are shown on the next slide. The label A indicates position of Alice's markers, and so on from there. Okay, so what that would mean, just to again give you an example of kind of what this would look like, if you're thinking about Alice, that means that Alice thinks that this segment would be an acceptable kind of answer, that this segment would be an acceptable piece to get, that this segment would be acceptable, and that this segment would be acceptable. And then the same, you can do a different color for B, for C, and for D. All right, so once we're done with the bidding, and again, I've just kind of talked you through this, we're now going to start with the allocations. This is the kind of tricky part. We're going to give to each child one of the segments in their bid. So scanning the array from left to right, we're going to look for the first marker to come up. And by first marker, we mean the ones with the number 1 below them. That first marker ends up being B1, which was Bianca. She decided that this segment of candy that you can see 1 through 4 would be an acceptable segment. She's going to receive her candy. Okay, so once she's received her candy, we're going to remove that from the list. We're then going to look for our next second marker. So when we're looking for our first second marker, we're looking at where are the 2s. And so you've got C2, D2, A2. C2 comes first. That means that from C1 to C2, this segment would be acceptable to Carla. So she's going to be the second player that's taken care of. Okay, once we've done that, we can remove those pieces of candy for Carla and keep going. So now we're looking for our first third marker. So looking at the threes, that means that Alice would be next up. We've got Alice from A2 to A3, pieces 12 through 16 would be an acceptable allotment for her. And so we'll remove those candies, which now means that we have one player left, which is Dana. And Dana had a marker D3 up to the end, which would give her 17 through 20. Now, here's kind of the cool part. After all of that, each player has gotten what they believe to be a fair share of the 20 pieces. The kind of cool part is that there are actually still 4 pieces left over. So when you divide the surplus, you can do that a bunch of different ways. One way is to draw lots and then let the player take turn choosing one piece at a time. That means that once they've done that, and it kind of talks you through that in the slide, that every player actually ends up with what they believe to be a fair share plus an extra piece of candy. The ideas behind this can easily be generalized to any number of players. We're just going to give a quick description of how that would work within players and in discrete items. So preliminaries, items are arranged into an array. For convenience, we'll label them 1 through M, going from left to right. The bidding works just the same. Each player takes turns dividing the array in segments by placing N-1 markers along the array. These segments are assumed to represent fair shares in the opinion of that player. Then we run through the allocation, similar to what we did before. We look for the first marker, and then we give the corresponding player, we'll call them P1, that bid. In the case of a tie, we just break the tie randomly. So we flip a coin, roll a dice, something like that. P1's markers are then removed from the rest of the array, and then we go looking for the second marker. We continue to do that, dividing up the candy or whatever it is that we may be working with. And then in step 3, whatever's left over, we divide the surplus out between the remaining players. Despite its elegance, method of markers actually can be used under some fairly restrictive conditions. Or it can only be used under some fairly restrictive conditions. It assumes that every player is to divide the array into segments that are about the same in value, meaning it's not like you're dividing it into 10 pieces of candy, 2, 3, and then 5 pieces of candy. They all have to be roughly the same. This is usually possible when the items are small and homogeneous in value. But it's very hard to do that when there's a combination of expensive and inexpensive items. For example, good luck trying to divide 19 candy bars plus an iPod using this same method. So, that being said, guys, that is it. We are done. It's been great working with you guys this semester. Again, be getting ready for that Chapter 3 quiz tomorrow. We've got midterm number 2 on Friday. Thursday is kind of the day that's set aside for your review day of sorts. And then remember, the final will be unlocked and available to you all of next week. We are off on Monday of next week, so it'll be available from you Tuesday at 8 a.m. all the way up through Friday at 4 p.m. Have a great rest of your day, everyone, and I will talk to you next time.